All right, here we go with 11.4. So go ahead and try the warm-up first. That's kind of what worked out well to have it come first. So this is going to be all about selecting and drawing conclusions from samples. So take a minute and pause the video and do the warm-up. Right, here you go. This is what you should have gotten. For this one, you could just throw it on the calculator and get 0.057. For here, I thought it might be easier to get rid of that square root because that's kind of yucky in the bottom. So I squared both sides right away. You might have taken a different path. And this is what happens when you square 0.025, and then it equals 1 over n. Then I got to get rid of that n in the denominator, so I multiply both sides with n by n, and this is what I end up with. And then all I have to do is 1 divided by 0.000625, and you get 1600 for an answer. If you went a different way, that's okay. I just kind of wanted you to see this way for later. All right, this is sort of back from 11.3, and so what I really was hoping you would do is write it as an inequality, something like that. Your score fell between 73 and 83. All right, let's look at this. A lot of vocab for this particular section. It's kind of a fun section, though. It's all about surveying people and samples. All right, a population is a group or people or objects that you want information about. For example, Dexter High School students. You want to find something out about what their opinions are for something. A sample is a subset of the population. So a subset of that sample could be all juniors. Unbiased sample is a sample that is representative of the population you want information about. So it's sort of like a way that you come up with to survey somebody that makes it unbiased. So there's a way you could do that by using the calculator. I'm going to jump right in and show you. This is really a cool little feature on the calculator. Let's say we want to survey for the prom theme, and we're going to survey only seniors. So what we're going to do is, I'd say there's about 231 seniors. So if you go to math and over to probability, there's this right here, number 5, it's called random integer, and you push that, and you tell it that you want, I don't think that's right, hold on, let me do it over. Math, 5, all right, now I'm going to tell the calculator that I want to choose one person, one number out of 231. Let's say there's 231 seniors. So what you got to do is you just kind of push the button, and it gives you a random number, and then you push it again, gives you another random number. So you could have numbered all of your seniors and say, okay, I'm going to go survey number 230, I'm going to survey number 47, I'm going to survey number 185. It's kind of a cool little random feature. It just gives you a bunch of random numbers. So that would be a way to get an unbiased sample. A biased sample is a question that elicits responses that do not accurately reflect the opinions or actions of the people surveyed. So for example, say you're standing in line at a concert and somebody decides they want to find out how many concerts people attend. So they decide to go to that concert line and ask people in that line. Well, that's a biased sample because obviously you're asking concert goers. And it would be better to get maybe a few from that line and a few just other random people somewhere else in a mall or whatever. Because if you only ask the people in the concert line, then it's a biased sample. Margin of error gives a limit on how much the response of a sample would be expected to differ from the response of the population. And then these are different methods for selecting a sample. Let me see if I can get this brighter. Hold on, it's coming, it's coming. All right, this is a little better. A self-selected sample. Okay, a self-selected sample is when members of a population volunteer to be in the sample. So I can kind of think of one that happened here when they handed out the sheets for you to vote for homecoming court. I kind of feel like that was a self-selected sample because those of you that were somewhat interested, you did it. But yet I had quite a few students that weren't interested at all, so they just didn't even do it. So that's a self-selected sample when you volunteer to do something or give your opinion. A systematic sample is a rule is used to select members of a population, such as selecting every third person that walks in the room. So I'm going to take a survey, and the way I'm going to get my survey responses is just choosing every third person that walks in a room. That's creating a system. You can think of it as a system. This is sort of people that volunteer. A convenient sample is an easy-to-reach members of a population are selected, such as those in the first row. Okay, those in the first row. I ask you a bunch of questions. That's convenience. Or if you want to survey favorite ice cream flavors, and you go to an ice cream store and ask people, well, that's just convenient because you know they like ice cream already. And so it's a convenient way to survey. A random sample is when each member of a population has an equal chance of being selected. And that again brings this little technique up here. That would be a completely random sample. All right? Oh, look! It's snowing! Yay! Finally, we're getting some snow. There you go, Claire. That was for you. Okay, so let's take a look at how we're going to use this. So, wasn't that fun? It was so pretty. All right. A manufacturer wants to sample the parts from a production line for defects. Identify the type of sample described. So the manufacturer has every fifth item on the production line tested for defects. So basically what he did was he came up with a system. Every fifth item. So that would be systematic. The manufacturer has the first 50 items on the production line tested. That would be purely convenience. He doesn't want to sit around, so he's just going to stand and take the first 50 items on the production line. So that would be convenience. All right. A magazine asks its readers to send in their responses to several questions regarding healthy eating. Tell whether the sample of responses is biased or unbiased. Well, to me, this would be biased because only the people that are really strong opinions about it are going to take their time to send in put their response, answer the questions, put their responses in an envelope with a stamp on it, and mail it in. So that's pretty much only a biased, it's a biased sampling. Only the readers with strong opinions are likely to respond. Okay? The owner of the company with 300 employees wants to survey them about their preference for a regular 5-day, 8-hour work week or a 4-day, 10-hour work week. Describe a method for selecting a random sampling of 50 employees to poll. Well, there's a few methods you could use, but probably the easiest may be to use our sampling right here. We could use the random integer samples, and we could just write down what the calculator comes up with and says, okay, I'm gonna interview number 25, I'm gonna interview number 230, etc., etc. That's a way to do it. Or you could put all the names in a hat. So you could use the random integer option on the calculator, or put all the names in the hat, and draw. Okay, the last thing we have to do is look at margin of error. So, this is how you might use it. In a survey of 1,535 people, 48% in this little pie chart here preferred brand A over brand B and brand C. So, what is the margin of error? So they did some sort of survey, and we want to include a margin of error of mistakes that might have been made in the survey to make it more accurate. So this here is just a little formula you can use to calculate margin of error. And N stands for your sample size. How many people were in the survey? So let's figure out what it is. So I'm going to do plus or minus 1 over the square root of 1535. And if I do that on the calculator, I'm going to get plus or minus 0.026. So now what I do to state that margin of error as a range, I would say give an interval that is likely to obtain the exact percent of all people who prefer brand A. Because you always have to consider, if you want to be exact, a little bit of a margin of error. So you would do 48% plus or minus 2.6%. 2.6%. So it kind of looks like this. Here's your 48, and you're going to go up 2.6, and you're going to go this way 2.6, plus 2.6, minus 2.6. And when you do that, you get 45.4% up to 50.6%. So this would be more exact as to the percentage of people that chose brand A. So there you go. All right. A state legislator conducts a poll to determine if the voters want to increase their property tax to make highway improvements. How many people were surveyed if the margin of error was plus or minus 3%? Well, they're giving me the margin of error. And I know that this is how you calculate margin of error. So this is just kind of like an algebra problem. I'm just going to keep it, it's a percentage, so I'm going to change it to decimal. And I'm going to set it equal to the formula here. 1 over the square root of n, plus or minus. We'll keep that in there for now. So here I have a little bit of an issue because I got the square root on the bottom. I'd like to get rid of that. So I'm going to square both sides. When I do that, I get 0.0009 equals plus or minus 1 over n. So I'm just going to do this for now. Okay, so what I want to do, I could keep the plus and minus up there, is I want to get rid of this n in the denominator. So multiply both sides by n. I get 0.009n equals plus or minus 1. And then if I divide both sides by 0.009, I am going to get approximately 1111 people. It's kind of a fun number. Now, since we're talking about people, we obviously would not consider the negative part of this equation. Okay, so just the positive. So that tells me there was about 111 people surveyed if the margin of error was 3%. And that is all. More snow. Yay! Isn't it pretty?